Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be learning about power series. This is an introduction to power series. Okay, we've worked with all these series tests. Now we want to talk about series almost written as a function. So let's take a look. A power series is a series that's written in the form the sum of a sub n times the quantity x minus c to the n power. So these are all examples of power series, okay? X minus 1 to the n over n factorial, x plus 3 to the n over n plus 1, x to the n over 2 to the n, all right? These are all examples of power series, okay? So now, if you notice, x is a variable. So n is the counter. It's going in wherever you see an n. But x is a variable, meaning that a number would actually go in there for x. Okay? And the idea is we want to figure out where power series converge and diverge. All right? In terms of x now, rather than just all in terms of numeric values like they were in the last half of the chapter. Okay, so here's the main idea. Earlier in the course, we wanted to discuss the convergence of a series such as this. So this series we know is a convergent geometric series. R is between -1 and 1. Now we want to discuss the convergence of this series, where x is a variable, okay, within there, meaning that if x changes, right, every time I put in a new value for x, it gives me a different geometric series. That geometric series could converge or it could diverge. I don't know, right? So I literally have to figure out how I can determine which values of x are going to make this thing converge and diverge. And that's what this part of the chapter here is all about. All right. So there are three possibilities for the convergence of any power series. Okay. First things first, the series only will converge at the center, x equals c. So c is called the center of this series. We're going to look at some series and their centers momentarily. We're going to go back and check out the three problems that we had up there earlier and talk about the center of that series. Case 2, the series converges at some distance away from the center, called the radius of convergence. All right, and we're going to see what that means in just a minute. Okay, it's pretty easy to understand, I think, once you understand the center of a series. And case 3, the series converges for any value x, meaning no matter what value of x you plug in here, the series would converge. All right, oh, that's the wrong way. Let's go back here for a minute. Okay, so again, if we look at this series, for example, there are certain values of x that if I substitute them in, it will give me an r value between -1 and 1. That would make this thing converge, right? There are certain values that would make the r value greater than 1, for example. Like if I plugged, 7 in. Well, if I plug 7 in for x, it gives me 5/3 to the n. 5/3 to the n is going to be a divergent geometric series. Okay? So that's what we're trying to do. We're trying to look for the values of x that will make this thing converge. All right? That's the concept behind it. Okay, so now, here's three examples of power series. Let's talk about the center. So again, the center is written inside with next to x. It's being added or subtracted. So if it's x minus 1, this power series is centered at c equals 1. X plus 3 is centered at c equals -3. And here, there's no number added and subtracted, so the center is 0. Okay, so it's possible that a power series can only converge at the center. And hopefully we agree that any power series will converge at its center, no matter what. Because if I substitute 1 in for x, well, 1 minus 1 is 0, so I get the sum of 0. Well, yeah, That's a convergent series. It converges to 0 because I just keep adding 0 over and over and over and over again. So, right? Same thing here. -3 plus 3 is 0. So I get a sum of 0. That's 0. Okay? So a power series has to converge as its center, at least. And then from there, it can also converge in other places. Like, for example, a series like this would converge in other places as well. If I substituted 3 in for x, well, 3 minus 2 is 1/3. 1/3 to the n, that's a convergent geometric series because r is between -1 and 1. All right? So that's what we're trying to look at here. Okay, so now let's talk a little bit about the radius of convergence before we finish up this video here. This is just a very basic introduction. And then in the next video, we're going to talk about how do you find the radius of convergence? How do you determine which values the series will converge for? Okay, that's coming up next. Okay, so suppose a series that's centered at 3 has a radius of convergence of 5. What conclusions can we draw about the series of the following values? All right, so now, just so that we understand, the radius of convergence is the distance away, how far away from the center the series will converge. So, for example, if the series is centered at 3, here's 3, and the radius of convergence is 5, that means I can go 5 units in either direction from 3, and I know the series converges. Now, I do have to be a little bit careful. I don't know what happens at either one of the endpoints. And you'll see why in the next video. Okay? I don't know what happens at either one of these endpoints. But I know that this series converges certainly for any value of x between -2 and 8. I know that for certain. All right? So, for example, let's say x were 1. If x is 1 in this case, well, 1 is between -2 and 8. So at x equals 1, this series will converge. How about x equals 10? Well, x equals 10 is outside of 8. So this series will diverge out there. Okay, and I can, again, if the radius of convergence is 5 and the center is 3, then I know for certain at x equals 10, which is outside of 8, the series will diverge. At x equals 3, well, 3 is the center. Okay, 3 is the center, so the series will converge here, no doubt. Even if I didn't know the radius of convergence was 5, I would still know the series converges at 3 because 3 is the center. Okay, so that's a very, very, very basic introduction to power series. And then click on the next video and we'll talk about how do you find this radius of convergence, figure out where the series will converge or diverge, and we'll go from there. As always, thanks for clicking.